Hey everyone, hope you are doing well. I was trying to think how to explain this video. I guess what I'm going to do is go over this, or this variety of questions. So we've got f of x is equal to x squared, g of x is equal to 5x cubed minus 2x, h of x is equal to sine of x, and k of x is equal to e to the power of x. We're going to differentiate all of these, and I'm going to give you some explanation along the way, so it'll give you a bit more understanding how to tackle these types of questions. So I suppose this is a bit of a variety video, because I guess traditionally, this is more classical differentiation, these sorts of questions, x squared, 5x cubed minus 2x, and these are slightly different or unique cases. So I guess it's kind of a bundle. If you want just a classical differentiation video, I should have one on my channel. I'll try and link it down below. And that's where you differentiate, y is equal to 5x squared plus 2x plus 1 and stuff like that, similar to these two. I mean, very similar to these, it's just written slightly differently. And these are quite unique, actually. So I will explain how to tackle them as well in this video. So I don't know if that intro really made sense, but let's jump into these questions so you can learn how to tackle these types of questions. So in this form, we have, so you might sometimes see, a formula like y is equal to x squared, and we need to work out dy over dx and what that is equal to. So if you have y is equal to x squared, dy over dx means differentiate, but the way it's written like this, when you have f of x, so it's a function of x, I guess, you can do like a little dash. So the comma there, and f dash, this is another, I guess, annotation, or another way to say you're differentiating. So this differentiated. Now, if you don't remember, when you differentiate an x squared, what you do is you bring the power down from the front. So you do 2x, and then you take 1 off the power. So that'd be 2 minus 1, which would just leave us with 1. You don't need to write if there's 1. And that's how you differentiate. That's the basics of differentiation. And I do have another video where I kind of go into it in a bit more detail, but you bring the power down from the top, and then you minus 1 from that power. So we'll do the same here. So, so g dash of x is equal to, bring that down here, so 15, I had to remember whether I was doing it right for a sec. So you bring the power down, you times it, so it'd be 15x, take 1 off the power, so you got 2, minus. So when you have an x here next to like a number, you can just get rid of the x, because what you're dealing with here is x to the power of 1. So you would effectively times the 1 to here, so it'd be minus 2x, and then take 1 off the power, so it'd be x to the power of 0. Anything to the power of 0 is 1. But, shorthand, you can just cross that out or bring it down here. And if you have a constant, like plus 7 or whatever, any constant will disappear, because that is 7 times 1, which is 7 times x to the power of 0. And, if you brought that power down, it would disappear. Now, you don't need to remember why. I mean, at least at this level anyway. Depends what level you're doing. But, you can get rid of the constants. That's a general rule for differentiation. So these are kind of like classical differentiation. That's how I'd describe them. These are a bit more different. Now, at least in sort of, I would say you probably wouldn't need to prove these or go into depth unless you were at, like, I would say advanced A level or at university level mathematics. So for the sake of this video, I'll tell you what they are, but I think for the next 2 videos, I might do proofs of these. So I'll prove the answer I'm about to show you. So again, we can do the h dash of x, and now this is going to be equal to cos of x. Now it feels like, I haven't done a lot of explanation, but I will link down that other video actually. But when you differentiate sine of x, so So you have sine of x, it becomes cos of x, and then it'd be minus sine of x, and then it'd be minus cos of x. And it goes in this cycle forever. So minus cos of x differentiated is sine of x, cos of x minus that. Now it gets a bit more complicated if you have like numbers in there and stuff like that, but when it's just simply sine of x, differentiated is cos of x, and it goes down in this cycle, it keeps going down. So I think I think I will decide to prove that. When you're proving things like that, you differentiate from first principles. Now, depending at your level, you might not need to worry about that. And I think what you do is you differentiate using first principles, and then you use like rules of sine and cos to show why this holds true. But for now, you probably just need to know that. And also for e to the power of x, it has another trick as well. So k dash x, that's differentiated with respect to x, is just going to be e to the power of x. Now, it's a bit different if you had like a 2 here or anything like that, but when you're differentiating e to the power of x, it's really nice and easy to remember. It just equals e to the power of x. Now, I think I will probably prove that as well with first principles in another video, because it feels a bit like a cop-out, but that's all you need to know, at least for this level. You know, when you differentiate e to the power of x, it's going to be equal to e to the power of x. Because you might have a question where it's like one thing times e to the power of x, and you've got to differentiate them both. But yeah, hopefully that makes sense. Hopefully it was clear. I realize it's a bit more of a generic video and we don't drill down too much into any of these, but you know, you can you can let me know if you have any comments or questions, anything like that, and I can try and get back to you there. Again, I will probably make my next 2 videos proving these. And as for these, I do have videos on differentiation, so you know, I probably have a couple at this point, so feel free to check them out, but I will give you a reference link below. So hopefully that makes sense. If you made it this far in the video, I appreciate you watching. Yeah, so thanks for watching, and best of luck with your maths.